In section 11.2, we're going to talk about properties of parallel lines. So I want you on page 660 to look at the gray box in the middle of the page. We're going to start with the second sentence since we did not do the solve it. You already know the relationship between vertical angles. In this lesson, you will explore the relationships between the angles you learned about in lesson 11.1 when they are formed by parallel lines. I want you to underline that, parallel lines, and a transversal. So here's your essential understanding. The special angle pairs formed by parallel lines and a transversal are congruent, supplementary, or both. So we're going to start with postulate 11 on the bottom of page 660. We're going to take the vocab word yesterday, same side interior angles, and we're going to make it a postulate. The same side interior angles postulate. So when you prove things in a theorem, you can either say same side interior angles postulate, or you can actually say the postulate, which is, if a transversal intersects two parallel lines, then same side interior angles are supplementary. You'll notice that in the diagram, it shows you that lines L and M are parallel. That's important. This only works if you have parallel lines. The transversal is the line that cuts through them. So, if you're looking at your same side angles, angle 4 and angle 5, and angle 3 and angle 6, each set are supplementary. So angle 4, the measure of angle 4, plus the measure of angle 5 is equal to 180, and the measure of angle 3 plus the measure of angle 6 is equal to 180. So if you need to pause the video and look over that, please do so. So in problem 1, you do not need to write this down because it's not in your book. It says the measure of angle 3 is 55. Which angles are supplementary to angle 3? And how do you know? So let's start with angle 3. We can see angle 3 is on the left side of your four angles on the bottom right. So angle 3, what angles do you think would be supplementary to that? Well, you should know that same side interior angles are supplementary. And by the way, notice these two little red triangles, which are drawn much better in the book. But these represent that those two lines are parallel. So we know that since those lines are parallel, angle 3 and angle 8 would be supplementary because they're same side interior. We also would know that angle 3 and angle 2 would be supplementary because of definition of supplementary angles. They form a straight line. We would also know that angle 3 and angle 4 would be supplementary for the same reason. Is there anything else that you see? Angle 3 and angle 6 would also be supplementary, and here's why. You will notice that angle 3 and angle 8 are supplementary because they're same side interior angles. What do you know about angle 6 and angle 8? Angle 6 and angle 8 are vertical angles, so they're the congruent. So therefore we know that 3 and 6 would also add up to 180, so they would also be supplementary. So all of these angles, 8, 2, 4, and 6, are all supplementary to angle 3. So then in the got it problem on the top of page 661, it says, if you know the measure of one of the angles, can you always find the measure of all angles when two parallel lines are cut by a transversal? And your answer would be yes, because all you need is just one angle. So for example, if you know 4 is congruent to 2, which is congruent to 8, which is congruent to 6. And then to find 1, 3, 5, and 7, angles 1, 3, 5, and 7 would all be the same because they're all supplementary to angles 2, 4, 6, and 8. So all you need is just one of these 8 angles to find the rest of them. On page 662, you have two more theorems. These are not postulates, these are theorems. Theorem 6, alternate interior angles theorem. Well, if a transversal intersects two parallel lines, once again they must be parallel, then the alternate interior angles are congruent. So it shows you in that picture that angle 4 and angle 6 are congruent, and angle 3 and angle 5 are congruent. In Theorem 7, corresponding angle theorem. If a transversal intersects two parallel lines, then corresponding angles are also congruent. So, as they give you an example, angle 1 and angle 5 are congruent, angle 4 and angle 8 are congruent, angle 2 and angle 6 are congruent, and angle 3 and angle 7 are congruent. So, looking at the bottom of page 662, you see a proof of Theorem 6. What they have done is they have proven that the alternate interior angles have been proven congruent. You will not need to know how to do that, but if you want to look over it, you can. So let's look at problem 2. In the got it problem on problem 2 on page 663, we have a proof, your favorite things. So we are given that A and B are parallel. Lines A and B are parallel. We have to prove that angle 1 is congruent to angle 7. So let's set up our t-table. All right, so I have set up the beginning of your proof. In step 1, A is parallel to line B. Those two lines are parallel. And we know that because that's given to us. We have to prove that angle 1 and angle 7 are congruent. So you have angle 1, 5, and 8 for a reason. So what do you think you're going to do next? We just talked about it in the last theorem. So we're going to say that angle 1 is congruent to angle 5. And why is that? Why is angle 1 congruent to angle 5? Because since we have two parallel lines, and that's important to note, you have to have parallel lines that are cut by a transversal, we're going to use the corresponding angle theorem. So your definition is going to be, or your reason is going to be, if lines are parallel, and remember, abbreviate, if lines are parallel, then corresponding angles are congruent. And that's the corresponding angles theorem. So then step 3, we know that angle 1 is congruent to angle 5. We now can say angle 5 would be congruent to what? Angle 7. Why is angle 5 congruent to angle 7? Because vertical angles are congruent. So let's look at what we have. Angle 1 is congruent to angle 5. Angle 5 is congruent to angle 7. So we can say angle 1 is congruent to angle 7. Why? Because of the transitive property. And you can put transitive property of congruency as well. Or you can just say transitive property. So we have just proven that angle 1 is congruent to angle 7. So let's go on and do problem 3 on the bottom of page 663. Supply the missing reasons in the two-column proof. So we're given that lines A and B are parallel, and we are given that lines C and D are parallel. We want to prove that angle 1 is congruent to angle 3. So in the first statement is our given, and you can actually also have C is parallel to D also in that first step. We know that angles 2 and 3 are supplementary. Why do we know that angles 2 and 3 are supplementary? Because we know that angle 3 and angle 2 are same side interior angles, so we're going to repeat the postulate. If two parallel lines are cut by a transversal, then the same side interior angles are congruent. You could also just say same side interior angles are congruent or same side interior angles postulate. B, angle 1 and 2 are supplementary. Well, angle 1 and 2 are also same side, so it's going to be the same reason. You're going to use the same reason as step A. So then in the last step, in step 5, which is C, it says that angle 1 and angle 3 are congruent. Why is that? This is a little harder. We've proven in step 2 that angle 3 and angle 2 are supplementary. In step 4, angle 1 and angle 2 are supplementary. So now we can say angle 1 is congruent to angle 3 because from a theorem that we learned a couple sections ago, that if two angles are supplementary to the same angle, then they are congruent. So A and B are the same reason, and C is now knowing that the steps 2 and 4 are both supplementary, that if we have two angles that are supplementary to the same angle, which in this case is angle 2, then angles 1 and angle 3 are congruent. At the bottom of page 664, we have Theorem 8, alternate exterior angle theorem. It's just like alternate interior, except now we're talking about the exterior angles. If a transversal intersects two parallel lines, then the alternate exterior angles are also congruent. Angle 1 and angle 7 are congruent, and angle 2 and angle 8 are congruent. If you know the measure of one of the angles formed by two parallel lines and a transversal, you can use theorems and postulates to find the measures of the other angles. All right, in problem 3, which is not in your book, we have this big chart, this big diagram. We have two parallel lines, P and Q, and we have two other parallel lines, L and M. And we have 8 angles not given to us, as well as 105 degrees. So, the measure of angle 3 and the measure of angle 4, I just want you to find those. What would the measure of angle 3 be? It should be 105 degrees, because angle 3 and angle 105, those are alternate interior angles. The measure of angle 4 and 105 are same side interior, so that means they're supplementary. So angle 4 would be 75 degrees. But it says which theorem or postulate justifies each answer. So I kind of said this, but we'll go back and repeat this. Measure of angle 3 is 105. Why? Because these are alternate interior angles, so this is the alternate interior angle theorem. The measure of angle 4 is 75, because 105 and 4 are same side interior angles, therefore we use the same side interior angles postulate. So those are the reasons behind it. So what I want you to do is to figure out, in your got it problem, the measures of angle 1, angle 2, and the rest of them from A through F. And then you tell me why they are what they are. Now, I have given you all of the answers from A through F. Here's the thing though, you can actually use multiple ways to find each of these. So I'll just do the first two to show you two different ways you can do this. You know angle A, which is angle 1, this angle right here, is 75. Now there are many ways you can get that. You can say because angle 1 and angle 2 are vertical angles, that they would be equal, so therefore you know angle 1 is 75. You could also say that the measure of angle 1 has to be congruent to the measure of angle 4 because these are alternate interior angles. So as you can see, there are many different things you can write. Angle B, which is angle 2, you could say angle 1 and angle 2 once again. You know 2 because angle 1 is vertical. You could have said this. Angle 4 is congruent to angle 2, and angle 2 is congruent to angle 4 because angle 2 and 4 are corresponding. So there are many different ways you can get these answers. In the got it problem on the top of page 666, in problem 4, you will see that we have a trapezoid. In this trapezoid, all you have to do is find the values of x and y. So you have to look at this and say, well, how am I going to write an equation? Well, you should know that because you have parallel lines, angles 2x and x minus 12 are same side interior angles. So we know that they're supplementary. So we can say 2x plus x minus 12 equals 180. We also can say 3y plus y plus 20 equals 180 for the same reason. They're same side interior. So now we can solve them. 3x, I'm going to add 12. That gives me 192. Divide by 3. X would be 64. Solve the other equation for y. Subtract 20. That gives me 160. Y would equal 40. So the value of x is 64, and the value of y is 40. So then part B asks, what are the measures of the four angles? Well, 2x, well, we don't need to write that, but 2x, we can say 2 times 64, that gives me 128. We could take 64 minus 12, which gives me 52. Plug in 40 for y, 3 times 40 is 120. And then 40 plus 20, that gives me 60. You could check all of them to make sure they add up to 360, which they do. And so your answer is 128 degrees, 52 degrees, 120 degrees, and 60 degrees.